It's not just about building muscle or shedding fat. There's a symphony of changes happening at the cellular level that play a crucial role in how our bodies adapt and respond to physical activity. By understanding these internal mechanisms, you can gain a deeper appreciation for the incredible complexity of the human body and how it rises to the challenge of exercise. Knowing what happens inside your body when you exercise is not only fascinating from an intellectual standpoint, but it also holds practical significance. This knowledge empowers you to make informed decisions about your fitness regimen, helping you optimize your workouts for better results. Additionally, understanding these internal processes can demystify certain sensations or reactions you may experience during exercise, ultimately leading to a safer and more effective fitness journey. Energy production. At the heart of every movement, from a brisk walk to an intense workout, lies a microscopic powerhouse called adenosine triphosphate, ATP. It serves as the primary source of energy for our cells. However, there's a limited reserve of ATP readily available in the body, so as soon as we start to move, our muscles call for more. This heightened demand for ATP is the driving force behind our body's need to produce more energy. As exercise intensifies, especially during activities like weightlifting or sprinting, this demand escalates, prompting our cells to ramp up their ATP production. One of the key processes responsible for replenishing ATP levels is glycolysis. This intricate biochemical pathway involves converting glucose, a type of sugar derived from the foods we consume, into ATP. This mechanism ensures a swift and continuous supply of energy, crucial for sustained physical exertion. Oxygen demand and cardiovascular response. As the intensity of exercise escalates, so does the demand for oxygen. Oxygen is the vital ingredient that fuels the process of creating ATP. This surge in demand triggers a cascade of physiological responses to ensure our muscles receive the oxygen they need to keep performing optimally. To meet this surge in oxygen demand, our cardiovascular system steps up to the plate. The heart begins to beat faster, propelling oxygen-rich blood more swiftly to our hard-working muscles. Simultaneously, our breathing rate increases, allowing us to take in more oxygen with each breath. This coordinated effort between the heart and lungs is what keeps us going during those challenging workouts. One crucial metric in this process is our maximum oxygen uptake, often referred to as VO2 max. This represents the upper limit of how much oxygen our body can utilize during intense exercise. Training to improve your VO2 max not only enhances your endurance, but also signifies a fitter, more efficient cardiovascular system. It's a key indicator of overall physical fitness and an important goal for many athletes and fitness enthusiasts. Blood flow and waste removal. During exercise, there's a remarkable increase in blood flow directed towards the muscles in action. This surge in circulation serves a crucial purpose. It ensures that these hard-working muscle tissues receive an ample supply of oxygen and nutrients, enabling them to sustain their activity. This enhanced blood flow is akin to a lifeline for the muscles, ensuring they get what they need to perform optimally. Simultaneously, this heightened blood flow plays a pivotal role in the removal of metabolic byproducts. As our muscles work, they generate various waste products, including lactate, phosphate, and hydrogen ions. These byproducts, if left unchecked, can impede muscle function and lead to that characteristic burning sensation we feel during intense exercise. The increased blood flow acts as a swift and efficient transportation system, whisking away these waste products, allowing the muscles to continue their work unhindered. While exercise brings about a surge in blood flow to our working muscles, it also leads to a temporary diversion away from other bodily functions, including digestion. This redirection of resources is a testament to the body's remarkable ability to prioritize vital functions. Consequently, digestion becomes somewhat impaired during exercise, emphasizing the importance of mindful eating habits and avoiding heavy meals immediately before a workout. Brain function and blood flow. Exercise doesn't just benefit the body, it's a boon for the brain as well. As we engage in physical activity, there's a notable increase in blood flow to the brain. This surge in circulation brings a fresh supply of oxygen and nutrients to this vital organ, essential for optimal cognitive function. This surge in blood flow to the brain translates into tangible benefits for cognitive processes. It has been shown to enhance learning and memory functions, particularly in areas of the brain responsible for these processes, such as the hippocampus. Additionally, increased blood flow heightens alertness and focus, leading to sharper cognitive performance both during and after exercise. The impact of exercise on specific brain regions is particularly noteworthy. The hippocampus, crucial for learning and memory, experiences a surge in blood flow during exercise, facilitating neurogenesis or the creation of new neurons. The hypothalamus, responsible for functions like body temperature regulation and water balance, responds dynamically to the increased circulation. Furthermore, the pituitary gland, a control center for hormonal responses, plays a key role in orchestrating the body's physiological reactions to exercise, including the release of cortisol, adrenaline, and growth hormones. Hormonal and neurotransmitter response. Exercise triggers a cascade of hormonal responses, with growth hormone taking center stage. While often associated with muscle growth, its primary role during exercise lies in mobilizing fat stores for energy. It also aids in preventing muscle breakdown, making it a valuable player in muscle maintenance. Beyond hormones, exercise unleashes a flurry of neurotransmitters, each with its unique impact on mood and well-being. Endorphins, the body's natural painkiller, contribute to the famed runner's high, creating a euphoric state after intense exercise. Dopamine, a key player in pleasure and reward pathways, is also elevated, contributing to feelings of satisfaction and motivation. GABA, with its tranquilizing and anti-anxiety effects, provides a sense of calm and relaxation. Finally, serotonin, renowned for its role in mood regulation, experiences a boost, promoting a sense of contentment and overall well-being during and after exercise. Muscle damage and soreness. When we engage in exercise, especially resistance training or activities that involve stretching, it's not uncommon for microscopic tears to occur within our muscle fibers. This phenomenon, known as muscle damage, is a natural part of the muscle adaptation process. It's a signal to our body that it needs to repair and reinforce these muscle fibers to become stronger and better equipped for future physical challenges. The aftermath of this muscle damage often manifests as soreness. This sensation, known as delayed onset muscle soreness, DOMS, is typically felt within the first 24 to 72 hours post-exercise. It's characterized by a dull, achy discomfort in the affected muscles. While it can be uncomfortable, it's important to recognize that DOMS is not indicative of severe injury. Instead, it signifies that the muscles have undergone a beneficial stressor, and they're in the process of healing and adapting. Recent research has brought about a reevaluation of the relationship between muscle damage and growth. It appears that excessive muscle damage may not be a prerequisite for muscle growth, and in fact, it might even hinder the process. A study published in the Journal of Applied Physiology in 2019 shed light on this, suggesting that focusing solely on inducing muscle damage may not be the most effective approach to muscle growth. Instead, it emphasizes the importance of balanced training methods that stimulate muscle growth without causing undue harm. Sweating and body temperature regulation. The intricate process of sweating is orchestrated by a tiny but powerful part of our brain called the hypothalamus. When our body temperature starts to rise during exercise or in hot environments, the hypothalamus sends signals to our sweat glands to start producing sweat. This process is finely tuned to maintain an optimal internal temperature and prevent overheating. There are two types of sweat glands at play in the thermoregulation process. Eccrine glands, found all over the body, release a clear, odorless perspiration primarily composed of water, salt, and small amounts of other electrolytes. On the other hand, apocrine glands are concentrated in areas with hair follicles such as the scalp, armpits, and groin. They produce a thicker, fattier sweat that can develop an odor when it interacts with skin bacteria. The purpose of sweating is to initiate a cooling effect. As sweat is released onto the skin's surface, it undergoes a process known as convection, where it evaporates into the air. This evaporation is akin to the body's natural air conditioning system, effectively dissipating heat and lowering our overall temperature. It's an elegant and efficient mechanism that allows us to continue exerting ourselves even in the face of challenging environmental conditions. Understanding these internal mechanisms should serve as motivation to fine-tune your exercise regimen and dietary choices. By doing so, you can maximize the benefits of your efforts, whether they be for strength gains, endurance improvements, or overall well-being.